Download this code from codegive.com, link in the description below. In-depth tutorial on channel binding in Go, golang. Channel binding in Go, golang, is a powerful technique that allows you to associate additional data with a channel without directly sending it as part of the channel's normal data. This is particularly useful for scenarios like contextual information passing metadata alongside the actual data being communicated. For example, you might want to include a timestamp, request ID, or error context along with the data sent over the channel. Avoiding boilerplate instead of wrapping your data in a custom struct just to add contextual information, channel binding lets you keep the data itself clean and simple while still conveying essential context. Clean separation of concerns decoupling the data payload from its metadata, leading to more maintainable and readable code. Security and authentication associating security tokens or authentication information with the channel connection itself, rather than embedding it in every message. Pipeline control adding control signals or instructions directly related to the processing of the data within a pipeline. How channel binding works, conceptually. Instead of modifying the type of data sent over a channel, channel binding involves using Go's concurrency primitives and closures to effectively associate a piece of information, the binding, with a specific channel operation, send or receive. Think of it as creating a bound function that wraps the standard channel operation. Methods for channel binding. There are several approaches to achieving channel binding in Go. We'll explore the most common and practical ones. 1. Using closures ***. This is perhaps the most straightforward and flexible approach. It leverages Go's first-class functions and closures to capture the desired binding information within a function that interacts with the channel. Code example Explanation send with context, ch_chan int, context string, func, int, takes a channel ch and a context string as input. Returns a closure, a function that captures variables from its surrounding scope. This closure takes an integer data to send on the channel. Inside the closure. It prints the data being sent along with the captured context. It sends the data value over the channel ch. Receive with context, ch_chan int, context string, func, int ***. Similar to send with context, but for receiving. Takes a channel ch and a context string. Returns a closure that takes no arguments and returns an int, the data received from the channel. Inside the closure. It receives data from the channel ch. It prints the received data along with the captured context. It returns the received data. Main, function creates an unbuffered channel ch. Creates a sender and receiver function by calling send with context and receive with context, each with its own context, request 123 and processor A, respectively. Launches a goroutine to send data using the sender function. Notice how the sender function is called like a normal function, but it already has the channel and context baked in. Iterates through the channel using for data equals range ch. This loop receives data from the channel until the channel is closed. Inside the loop, it calls the receiver function to receive data from the channel. Again, the receiver function already has the channel and its context. Important the close, ch, statement in the sending goroutine is crucial. It signals to the receiver loop that no more data will be sent on the channel, allowing the loop to terminate gracefully. Benefits of closures asterisk. Asterisk simple and readable asterisk the code is relatively easy to understand. Asterisk flexible asterisk you can capture any data you need in the closures scope. Asterisk maintainability asterisk the binding logic is encapsulated within the functions, making it easier to modify or debug. 2. Using custom types with methods asterisk asterisk. This approach involves defining a custom type that holds both the channel and the binding information. Methods on this type then perform the send and receive operations, leveraging the stored context. Code example asterisk. Explanation asterisk. Asterisk bound channel struct asterisk defines a type that holds a channel, ch, and a context string, context. This is the container for our channel binding. Asterisk new bound channel, function asterisk a constructor function to create instances of the bound channel struct. Asterisk send, method asterisk a method on the bound channel struct that asterisk prints the data being sent along with the context stored in the bound channel instance. Asterisk sends the data to the underlying channel, bc.ch. Asterisk receive, method asterisk a method on the bound channel struct that asterisk receives data from the underlying channel, bc.ch. Asterisk prints the received data along with the context stored in the bound channel instance. Asterisk returns the received data. Asterisk main, function asterisk. Asterisk creates a channel ch. Asterisk creates a bound channel instance, passing the channel and context. Asterisk launches a coroutine that uses the send method of the bound channel to send data with the bound context. Asterisk iterates through the channel, using the receive method of the bound channel to receive data with the bound context. Benefits of custom types asterisk. Asterisk object-oriented approach asterisk provides a more structured way to manage channel bindings, especially in larger projects. Asterisk encapsulation asterisk the channel and its associated context are neatly encapsulated within the bound channel type. Asterisk extensibility asterisk you can easily add more methods to the bound channel type to perform other operations related to the channel and its context. 3. Using a struct to represent messages with context. This method wraps the data sent over the channel into a struct that also contains the context. It is different from the previous two approaches, as the type of the channel itself changes. Code example asterisk. Explanation asterisk. Asterisk message with context struct asterisk defines a struct to hold both the data, and the context, Asterisk ch equals make, chan message with context, asterisk the channel is now a channel of message with context structs. This is the key difference. Asterisk sending and receiving asterisk the sending and receiving logic now directly deals with the message with context struct. Benefits of struct-based messages asterisk. Asterisk explicit asterisk the context is explicitly part of the data type, making it very clear what is being sent. Asterisk simple to understand asterisk easy to read and reason about, especially for developers new to Go. Disadvantages asterisk. Asterisk less decoupled asterisk the data and context are tightly coupled, which might not be ideal if you want to change the context independently of the data. Asterisk more boilerplate for simple cases asterisk for very simple scenarios, wrapping the data in a struct might feel like unnecessary overhead. Choosing the right approach. The best approach for channel binding depends on your specific needs and the complexity of your application. Asterisk closures asterisk use closures when you need a simple, flexible, and concise way to associate context with channel operations, especially if the context is relatively simple, example a single string. Asterisk custom types with methods asterisk use custom types when you want a more structured, object-oriented approach, and when you need to encapsulate the channel and its context within a well-defined type. This is suitable for larger projects where maintainability and organization are crucial. Struct-based messages use structs for the data when the context is inherently part of the message being communicated, and you prefer the explicitness of having the context directly included in the data type. This is a good choice if you need to serialize the message, including the context, or if you're working with data that naturally has associated metadata. Important considerations channel direction channels can be unidirectional, send only or receive only. Be mindful of the channel's direction when creating your bound send and receive functions. If you have a send-only channel, you can only create a send with context function, or similar. Channel closing always close the channel when the sender is finished sending data. This signals to the receiver that there will be no more data, allowing the receiver loop to terminate gracefully. Failing to close the channel can lead to deadlocks. Error handling in real-world applications, you'll want to add proper error handling. For example, you might want to send errors over a separate error channel along with your data. You could also include an error field in your message with context struct. Concurrency safety remember that channel operations are inherently concurrent safe. However, if you are modifying any shared data within your bound functions, besides just sending/receiving on the channel, you'll need to use appropriate synchronization mechanisms, example mutexes, to ensure data consistency. Complete example with error handling, closures. Key improvements in the error handling example error channel an ARCH is introduced to communicate errors back to the main coroutine. Timeouts select statements with time after are used to prevent indefinite blocking when sending or receiving. Error handling in send with context and receive with context these functions now send errors to ARCH if a timeout occurs. Error handling in main the main function now checks for errors after each receive operation. Buffered error channel the ARCH is buffered, make, chan error, 10, to prevent blocking the sender if the main coroutine isn't immediately ready to receive errors. Exit on error the receiver loop breaks if an error is encountered, preventing further processing. Channel open check, the receive loop checks if the channel is open after it has reached an empty state to prevent a deadlock scenario. This enhanced example demonstrates how to incorporate robust error handling into your channel binding code, making your applications more resilient and reliable. By understanding these techniques and considerations, you can effectively leverage channel binding to create more sophisticated and maintainable concurrent programs in Go. Remember to choose the approach that best suits the specific requirements of your application and always prioritize clear error handling and concurrency safety.